In this lesson you will learn about circles. In this circle shown, we have the center illustrated with this bold dot and the letter A. So to name this circle, we would say that this is circle A, and the symbol for circle is a circle with a dot in the middle to represent the center, and we always use a capital letter. So in circle A, we have a radius, and the radius is the distance from the center to any point on the circle. So this length here is one radius, and then we have another length here, another radius, and if I drew my own line here, that's still another radius, and plural for radius is radii. All radii are equal. So if one radius has a length of 5, they all have a length of 5. The next definition for circles is diameter. And the diameter is the distance across the circle that passes through the center. So the length from here to here is one full diameter. And since the diameter is made up of 2 radii, double the length of the radius to find the diameter. Pi is the ratio of the circumference to the diameter. And there are 2 values of pi that we will use. One is 3.14 and the other is 22/7. I only use 22/7 when the number that I'm multiplying by is a multiple of 7. Otherwise, I will use the value of 3.14. The circumference is the distance around the circle, and it has 2 formulas, either 2 pi r, 2 times pi times radius, or pi d, pi times diameter. You can use either one. Use 2 pi r if the radius is given. Use pi d if the diameter is given. And the last formula is area, and area represents the amount of space inside the circle. The formula is pi r squared. And the last thing you want to remember about circles is that all circles contain 360 degrees. So for the first 3 questions, we want to find the circumference of the circle, 1 in terms of pi, and then 2 rounded to the nearest tenth. So in number 1, we are given a radius equal to 12. So I have 2 formulas for circumference, and the formula that I will use is the one that involves the radius, 2 pi r. So in terms of pi, circumference is 2 times pi times 12, which is 24 pi, and circumference has the same units as the problem. The radius was measured in meters, so the circumference is 24 pi meters. To round this to the nearest tenth, I take 3.14 and multiply it by 24, so that I get 75.36, but to round this to the nearest tenth, we would write this as 75.4 meters. For number 2, we're given the diameter, and the diameter is equal to 28 centimeters. So this time the formula that I'll use for circumference is pi d. D represents diameter, so I take pi times 28, and you could write it as pi 28 or 28 pi. Usually you see the number first and the pi symbol second when you're writing it in terms of pi. Just make sure you include the units. So the circumference in terms of pi is 28 pi centimeters. And then to do this problem again, round it to the nearest tenth, since 28 is a multiple of 7, I'm going to use the second value of pi, which is 22/7. Because when I use 22/7, the 7 reduces to 1 and the 28 to 4 so that I get 88. So you can also write the circumference as 88, but since we have to round to the nearest tenth, we'd have to include 0.0 and then the units of centimeters. For number 3, this circle has a radius of 3.5 inches. So if I use the formula, C equals 2 pi r, I have C is equal to 2 times pi times 3.5. And if I take 2 times 3.5, 2 times 3.5 is equal to 7. So in terms of pi, the circumference is 7 pi inches. Now to round this to the nearest tenth, I take 7 pi and I substitute one of the values in for pi. And the one that I will use is 22 over 7 because the number 7 is a multiple of 7. The 7's cancel and I'm left with 22. And we have to round this to the nearest tenth, so I have to add a 0.0 and then the units of inches. For number 4, we're asked to find the radius of the circle if the circumference is equal to 60 feet. So we know that the circumference formula is equal to 2 pi r or pi d. So for this problem, I'm going to take 60 and I'm going to substitute it into this formula because I'm asked to find the radius. So I have 60 equals 2 times pi times r, and the easiest thing to do first is to divide both sides by 2 so that I get 30 is equal to pi times the radius. Then to find the radius, I have to divide both sides by pi so that the pi's cancel and I'm left with the radius is equal to 30 divided by pi. So if I'm taking 30 divided by pi, that's the same as 30 divided by 3.14. So if I take 3.14 and divide that into 30, I want to move my decimal point over twice so that I have 3,000. I add 2 zeros inside, and if I take 314, I'd have to divide it into 3,000, and 314 times 9 is equal to 2,826. And if I subtract that from 3,000, I get 174. If I take 5 times 314, I get 1,570. And if I subtract that, I get 170, add another 0, so that I have 1,700. And then one more time I can multiply by 5, but I don't need to keep going because I'm just asked to round to the nearest tenth, so I know that my radius is equal to 9.6. And 9.6 will be in feet because the original circumference was in feet. So this is one way you could solve it. Another way you could solve this is you could take 60 and put it into the other circumference formula, and then you have 60 equals pi times diameter. And when you divide both sides by pi, the diameter is equal to 60 divided by 3.14. So I won't carry through with the long division on this one, but after you divide by 3.14, you would then have to divide by 2 because the question is asking for the radius and not the diameter. Either way, you'll get an answer of 9.6 feet. For questions 5 through 7, we want to find the area in terms of pi and then round the answer to the nearest tenth. So we are given a radius equal to 12, and there's only one formula for area, which is pi r squared. So in terms of pi, I take 12 and substitute it into the radius, and my answer is 144 pi, but the units for area are square units. So it's 144 pi meters squared. That's my answer in terms of pi. Now rounded to the nearest tenth, I have 144 pi. So I take 144 times 3.14, multiply them together, and then I'll round it to the nearest tenth. And rounded to the nearest tenth, we have 452.2 square meters. For number 6, we're given the diameter is equal to 28. Since the area formula only involves the radius, I want to find my radius by dividing 28 by 2 so that I get 14. So now when I find the area, it's pi times the radius squared, and 14 times 14 is equal to 196. So my area in terms of pi is 196 pi, and my units are centimeters, so 196 pi centimeters squared. Now to round this to the nearest tenth, 196 pi, I'm going to write this as 196 times 22 over 7, because 7 is a factor of 196. So if I divide 196 by 7, I get 28, and then times that by 22, I get 616. So because we're asked to round this to the nearest tenth, we have to write this as 616.0 centimeters squared. It's okay if you use 3.14 instead of 22 over 7. Just make sure you round your answer to the nearest tenth and include the units. Area is always in square units. For number 7, we're given a radius equal to 3.5. So 3.5 as an improper fraction is 7 over 2. So when I find the area of a circle, pi r squared, we have to take the radius of 7 over 2 and square it, so that the area is equal to pi times 49 over 4. So we can write this as 49 pi over 4. Now this can also be written in terms of pi if we take 4 and divide it into 49 and write this as a mixed number or a decimal, 4 times 12 is 48 with 1 left over, so 12 and 1/4 is the same as 12.25. So we can write this as 49 pi over 4 inches squared, or 12 and 1/4 pi inches squared, and still one more way in terms of pi as 12.25 inches squared. So these are the three ways the answers can be expressed in terms of pi. But when we round this to the nearest tenth, I will use the 12.25 pi formula For number 7, we're given a radius of 3.5. And I'm going to write that 3.5 as 3.5. The reason why for number 7, we're given a radius of 3.5. I'm going to write that 3.5 as 3.5. The reason why is because the area formula is pi r squared. And we are going to have to take that radius of 3.5 and square it. So I'm going to do the squaring on the side. 3.5 times 3.5. Whenever you square a number, you multiply it by itself. And I get 12.25. You could have left this as 3.5 and then converted it to an improper fraction. That would have been acceptable too. But as a decimal, this is 12.25 pi. Our units are inches, and we always square the units when we're dealing with area. So the area is 12.25 pi inches squared. Now to round this to the nearest tenth, I will take 12.25 and multiply this by 3.14. And I move my decimal point over 4 times so that I have 38.4650, and rounded to the nearest tenth, I have 38.5 inches squared. For number 8, we want to find the radius of a circle if the area is equal to 60 square feet. So 60 square feet is the same as 60 feet squared, and the formula for area is pi r squared. So since 60 represents the area, I'm going to substitute that in for a, so that I have 60 is equal to pi r squared. And to solve for the radius, I first have to divide by pi. So I won't be getting the value of r right away. I'll be getting the value of r squared. R squared will be equal to 60 divided by 6.1. 3.14. So if I take 3.14 and divide it on the side, we move our decimal point over twice so that we have 314, and now we add 2 zeros so that we have 6,000. So 314 times 1 is the most times that 314 divides into 600, and if I take 600 minus 314, I get 286, bring down a 0, and then 314 times 9 is 2,826, and when I subtract, I get 34, add a 0, 314 divides into 340 once, and when I bring down my next 0, I only have 260, so I would have to add another 0, so I just add a 0 on top, and so my radius squared is equal to 19.10. Now we're not finished because we want to find the radius. So if you're allowed to use your calculator, you can just take the square root of 19.10. If you don't have a calculator and you have to estimate this in your head, then take the two perfect squares of 16 and 25, and I would estimate 19.10 to be a little bit less than halfway, which would make the square root of 19.10 approximately 4.4. So the radius is equal to 4.4 feet. For number 9, find the area of the shaded region if the radius of the larger circle is 10 meters and the radius of the smaller circle is 8. So this radius here is 8, whereas this radius here is 10. If we want to find the area of the shaded region, we want to take the area of the larger circle and subtract the area of the smaller circle. For both areas, we'll be using the formula pi r squared, and the radius of the larger circle is 10, the radius of the smaller circle is 8. So the larger circle, in terms of pi, has an area of 100 pi, and the smaller circle, in terms of pi, has an area of 64 pi. So the shaded region has an area of 100 pi minus 64 pi, which is 36 pi. And because the units above were in meters, we had 10 meters for the large radius, 8 meters for the small radius. We would write this as meters squared because area is always in square units. For number 10, find the total distance traveled if a bicycle has a diameter of 20 inches and it makes 5 revolutions. So here's our bicycle wheel, and it has a diameter of 20 inches. So every time a bicycle makes a revolution, it covers a certain distance on the road. So if it makes 5 revolutions, we have 5 lengths of the circle, and to find one of these lengths, the formula for the circumference of a circle is pi times diameter. So since the diameter is 20, then the circumference is equal to pi times 20, which is 20 pi. So we have 5 revolutions, and 20 pi times 5 is equal to 100 pi. So our total distance traveled is equal to 100 pi, and distance or circumference is always the same units. So the diameter was given in inches, so it's 100 pi inches. And on the side here, if I take 3.14 and multiply it by 100, all you're doing is moving the decimal point over 2 places so that this is the same as 314 inches. So 100 pi is the answer in terms of pi, and 314 inches is an answer as a whole number. For number 11, we have the radius of a circle is doubled. What is the ratio of the circumference of the smaller circle to the circumference of the larger circle? So if I draw 2 circles, and I pick a value for the radius of the small circle, I'll just use the number 2, but I have to double it for the larger circle, so this radius would be 4. So I have a smaller radius of 2, a larger radius of 4, and if I'm comparing the circumferences of the circles, I'll use the formula 2 pi r for both circles. So when I substitute the radius of 2 into the smaller circle, I get a circumference of 4 pi. When I substitute the radius of 4 into the larger circle, I get a circumference of 8 pi. So the ratio of the smaller circle to the larger circle is 4 pi over 8 pi. The pi's cancel, and 4 over 8 reduces to 1 over 2, so the ratio is 1 to 2. For number 12, it's the same problem, except now we're asked to compare the areas. So I'm going to draw the same 2 circles, one with a radius of 2 and the other with a radius of 4. And the smaller circle has a radius of 2, the larger circle has a radius of 4. This time I'm comparing areas, so I'm using the area formula, pi r squared for both circles. So we have pi times 2 squared gives us an area of 4 pi. And for the larger circle, we have pi times 4 squared gives us an area of 16 pi. So we want the smaller circle's area to the larger circle's area. The pi's cancel, and 4 over 16 reduces to 1/4, so the ratio is 1 to 4. For number 13, Frank is planting a circular garden with a diameter of 6 feet. So if this is the circular garden with a diameter of 6 feet, the first question is approximately how much fencing is needed to surround the garden. So if you're finding the amount of fencing needed to surround the garden, that's a measure of circumference because it's the distance around the circle. So I will use the formula C equals pi d, and we know our d is equal to 6, so the circumference is equal to pi times 6, which is 6 pi, and this one I'll multiply out on the side by 3.14, and rounded to the nearest tenth is 18.8, so he would need 18.8 feet of fencing to surround the garden. And for this one, I'm going to round it up to the nearest whole number and say 19 feet. So he would need 19 feet of fencing to surround the garden. The second question asks for the minimum amount of soil needed to cover the garden. When you're covering the garden, that is the amount of space that's inside the garden. So that's a measure of area. For the next question, we're asked to find what is the minimum amount of soil needed to cover the garden. Since the soil is covering the garden, that is a measure of area, or the amount of space that's inside the garden. So to use the area formula, area equals pi r squared, we need the radius, and since we have a diameter of 6, we have a radius of 3. So the area is pi times 3 squared, which is 9 pi. And if I take 3.14 and multiply it by 9, I get 28.26 square feet. And this I'm also going to round up, because if we rounded down to 28, we really wouldn't have enough soil to cover the garden. So I will say approximately 29 square feet of soil is needed to cover the garden.